Pulse Electronics inside 5G. 5G. We've all heard of it, but what is it? Is it already here? And what will it do? By definition, 5G is the fifth generation of mobile networks. The first mobile network, 1G, launched way back in 1983, and since then, the uses and complexity have grown exponentially. These mobile networks can be divided into two realms: the supply side infrastructure and the demand side devices. The supply side infrastructure consists of the centralized servers, cell towers, base stations, fiber, edge servers and small cells, and all the supporting software that enables the communication. The demand side devices consist of all the things that will consume and create the data: the cell phones and tablets, autonomous vehicles, transportation infrastructure, machines, security systems, smart utilities, smart homes, smart cities, and smart farms. The rollout of 5G has already begun, but full-scale adoption will take years. It is estimated that by 2025, half of mobile connections will already be 5G. Pulse Electronics is inside 5G. Our networking components and SFP cages facilitate communications across copper and fiber. Our wireless antenna components enable through-air communications, and our power magnetics components ensure that the system runs efficiently. But what is really driving the need for a better fifth-generation network? Today, humans, through their devices, either talk to other humans or request services from computers. And although our needs will continue to grow, this is not the real driver for 5G. The exponential need comes as we implement massive machine-type communications, where the machines, through their software, will talk to other machines. It is estimated that by 2025, there will be 100 billion such machines, or 12 times the human population. They will control critical infrastructure in healthcare, in energy management, in policing, and in transportation. And to do so, require higher communication speeds, higher bandwidth, and lower latency. And this is what 5G promises. Speed is the rate at which data can be downloaded. Although 5G will continue to leverage existing 4G low-band and mid-band radio networks for longer haul signals, the breakthrough for 5G is in utilizing a new higher frequency band, high band or millimeter wave, for short distance signals. The problem with high frequency is that the short wavelength signals have trouble going through or around obstacles. To ensure coverage, 5G will need to deploy up to 400 times more macro and small cell transmitters than are currently used in 4G. The new frequency band, along with more complex communication protocols, will increase average speed from 40 megabits per second to 600 megabits per second, or 15 times. This reduces the download speed of a television series from 70 seconds to 4 seconds. Bandwidth is the maximum amount of data that can be transmitted at the same time. The problem with today's 4G is that the low and mid bands are crowded, and there's no more spectrum available, which slows down traffic. The new millimeter wave has lots of room, and therefore the amount of traffic can be increased dramatically. Bandwidth increases from 200 megabits per second to 1 gigabit per second, or 5 times. This translates to the ability to service 1,000 times more users per given area. Latency is the time it takes for devices to communicate with each other. It is the inherent delay. 5G will employ localized edge servers to store information closer to the users. 5G small cells will also be able to track users and direct communications to them, more like a spotlight instead of the existing floodlight approach. These factors, along with changes in the information packets, means that latency within the 5G system will be reduced from 50 milliseconds to 1 millisecond, or 50 times. Put in context, the delay in humans between seeing an object and the brain receiving the image is 10 milliseconds. 5G will be 10 times faster than humans. 5G will continue to use a combination of through-air radio frequency signals, through fiber optic cable light signals, and through copper electrical signals to move data from source to user. More small cells, new base stations, additional edge servers, and thousands of new devices communicating within the 5G ecosystem. This means more networking components, more power magnetics, and more wireless antennas. So what can Pulse Electronics offer that goes inside 5G?